Hello my dear students. Now today we are going to learn integration by parts. This is the second method of integration. So this is a very easy topic because there is only one formula which you need to understand. So first let us try to understand when do I use integration by parts. Is that clear? So whenever the question is of the form integration u dot v dx, that means there are two functions being multiplied with each other such that, but please keep in mind that substitution should not be applicable. When you differentiate the first function, you don't get the second, and when you differentiate the second function, you don't get the first. In such a case, we use integration by parts. Okay, so out here, the first thing you need to know is you need to identify which one is the first function and which one is your second function. And the rule that is to be used is ILATE, ILATE, or in some books it's LIATE. That does not matter. So what does this mean? I stands for inverse. I stands for inverse function, sine inverse, cos inverse, tan inverse. L stands for log function. A stands for algebraic. Algebraic means x square, x cube, x to the power 4. T stands for trigonometric. Trigonometric means sin x, cos x, tan x, sec x, and E stands for exponential. So this rule will help you identify which is the first function and which is the second function. Once you identify the first function and the second function, you simply have to use this formula. The rule is the first function. That means let us say that this becomes your first. So the first function, keep it as it is, integration of the second function minus integration, curly bracket, differentiation of the first function, and then integration of the second function, close the curly bracket, dx. So this formula is called integration by parts. Okay, so let us say that u is the first function and v is the first function. Then the formula becomes u integration of v dx minus integration curly bracket d by dx of u into integration of v dx, close the bracket, dx. So this is called integration by parts. So as you can see, the order of u and v is same. It's just that the first term u remains constant, integrate the second, and in the second part you differentiate the first and then integrate the second. This is called integration by parts. This you are going to get this particular topic in page number 368. Page number 368, it is integration by parts. So as you can see, as I've already told you, the integration by parts is not that difficult. It's just that you need to know this formula. Is that clear? So first let us see the difference between substitution and by parts. Now I'll give you a similar type of problem. So look at this. This is, let us say this is 1 by x into log x dx. 1 by x into log x dx, and the other one is another question. Question number 2 is integration x into e to the power x dx, equation number 2. Now both questions are of the form integration u into v dx, yes or no? This is your u and this is your v, and this is your u and this is your v. But the method to solve these two are different. Now what did I say? When you differentiate the first, you don't get the second, and when you differentiate the second, you don't get the first. Then we use integration by parts. But in this case, differentiation of 1 by x is minus 1 by x square. That you are not getting, but when you differentiate the second part, log x, unto getting 1 by x, that means in the first equation we use substitution and in the second equation we use method of integration by parts. Is that clear? So this is how you differentiate between problems and identify which method to be used. So let us solve this first, which we have already done. 1 by x log x dx. So isn't this question also in the form u into v? But out here I cannot use by parts, because when you differentiate log x, we are getting 1 by x. So we don't use by parts, we use substitution. So what is the rule of substitution? Let log x equal to z. So differential log x is 1 by x dx equal to dz. So substitute, instead of 1 by x dx, I can write dz, and instead of log x I can write z. So this becomes z to the power 1. So integration of z to the power 1 becomes 1 plus 1 is 2 divided by 2 plus c. So your answer is, what is the value of z? It is log x whole square by 2 plus c. So this is the solution to the first equation. Now let us see the solution to the second equation. X dot e to the power x dx. Now isn't this question also of the form u into v? But the problem out here is we cannot use substitution out here, because in the first class which I have explained, I have told you whenever there are two functions we always try substitution. So if substitution does not work, then the second option that you have is by parts. So when you differentiate x, differentiation of x is 1, you are not getting e to the power x, and differentiation of e to the power x is also e to the power x, that means you are not getting x. So for this particular question we cannot use integration by substitution, so we have to use integration by parts. So what was the rule? ILATE. So what does x mean? It's algebraic. And what does e mean? Exponential. So from the order you can see that a, that is algebraic, is the first term. It's not that since x is the first term, this becomes u. No, you have to look at this rule. So using by parts, what does by parts say? So this becomes your u and this becomes your v according to the rule. Okay, so the rule is by parts is u integration of v dx minus integration curly bracket differentiation of the first function into integration of the second function. So just apply this, you'll get the value. What is u? U is x integration of e to the power x dx minus integration d by dx of what is u? The first function is x, and integration of the second function is e to the power x dx, close the bracket, dx. Now you get x integration of ex, formula ex minus integration, differentiation of x is 1 and integration of e to the power x is e to the power x dx. So you are left with x dot e to the power x minus e to the power x into 1 is e to the power x dx. Now the first step is simple application of formula. You might have problems with the second step. Second step means this integration. The reason why is if you come across two functions, then again you have to use the methods which we have already discussed, that is integration by substitution. But since out here only one term is left, so you can simply apply the formula and get the value, that is x dot e to the power x minus e to the power x plus c. So as you can see clearly, I have explained substitution and integration by parts by giving you two identical type of questions, and I have explained how you can identify which question is to be solved by which particular method. So is that clear? So we will be discussing few more questions on integration by parts. So the question will be of the form integration u into v, that means there will be two functions, and the criteria to be followed is when you differentiate the first you don't get the second, and when you differentiate the second you don't get the first. Is that clear? So in such a case we use integration by parts, and we have to identify the first function and the second function, and the rule that is to be used is ILATE. In some books it's LIATE. It does not matter because inverse and log will never be together. So whether you write IL or LI, it does not matter. Okay, now moving on, just few more examples. Integration x into log x dx. Okay, now look at this particular question, integration x log x. Now you can see two functions, differentiate x, it's 1. You're not getting log x. Differentiate log x is 1 by x. You're not getting x. That means we use by parts. So the rule is ILATE. So I stands for inverse. There is no inverse function. L stands for log. Yes, log is there. So this becomes your U and this becomes your V. So using by parts. So remember what I told you. The first formula is not a problem. So the formula is integration, first function integration of the second function minus integration curly bracket differentiate the first function and integrate the second function. So just put the value. What is U? U is log x. So log x integration of what is V? It is x dx minus integration curly bracket differentiation of log x, the first function, into integration of the second function. So simplifying this is not a problem. So log x as it is, what is the integration of x? The power of x is 1. So you know when you integrate the power increases. So this becomes x square by 2 minus integration differential log x is 1 by x into integration of x is 1. So 1 becomes x square by 2. Remember what I told you? This just applying formulas of by part is easy, but the second integration which you see out here might cause some problem. But in this case, the reason why it might cause problem, there might be two functions, but in this case, since we got two functions, but since the functions are same, we can cancel them and make it 1. So when you get only one function, then you simply apply the formula. So x and x gets cancelled. So your final answer is x square by 2 log x minus 1 by 2 comes out, integration of x dx. So your answer x square by 2 log x minus 1 by 2 integration of x is into x to the power 1. So this becomes x square by 2 plus c. So this is how you solve problems in using this method, that is called integration by parts. Is that clear? Okay. So once you have understood the method, most of the times you get two questions from by parts. One is application of formula and the other one is property. So in this class, I'm going to explain the use of property also. Is that clear? So the property says, a very important property which we will be using. Integration, the property says integration e to the power x, open bracket, suppose there is a function f and the second function is the differentiated value of the function, then the value of this integration is going to be e to the power x into f plus c. This is the property and this you get by using by parts. Is that clear? So first we are going to apply the property directly, then we are going to show how we got the final result without using the property also. So for example number 1, integration e to the power x, open bracket, sin x, whatever be the first, the second must be the differential value of the first. That means what is the differentiation of sine? So it is cos x, isn't it? So this particular question satisfies this particular property because whatever is the first function, the second must be the differential value of the first. That means differentiation of sine is cos x, isn't it? So according to the property, the answer must be e to the power x into the function, that means sin x plus c. This is the answer according to the property, isn't it? But I'm going to teach you how you are getting e to the power x sin x also. So just have a look. Open the bracket, e to the power x sin x dx plus integration e to the power x cos x dx. So as you can see that we split this question into two parts, e to the power x sin x and e to the power cos x. Out here also there are two functions being multiplied, and out here also there are two functions being multiplied, so I have to use by parts. So apply by parts only for the function, that means for the sin x. So tell me the rule. ILATE, E stands for exponential and sin stands for trigonometry. So this is the first function. So what is the formula? First function, integration of the second minus integration curly bracket differentiation of the first function into integration of the second function, plus the second part as it is. We don't use by parts for this. Understood? Now simplify this and see what you get. Sin x as it is. What is integration of e to the power x? It is e to the power x minus what is the differentiation of sin x? It is cos x. And what is the integration of e to the power x? It's e to the power x dx plus the term which was left, e to the power x cos x dx. So as you can see, this is positive and this is negative, and both the integrations are same, so positive and negative gets cancelled. So your answer is e to the power x sin x plus c, which we had already got. So this is by applying by parts, and this is by applying the property. Is that clear? So we'll do some more questions where we use the property. So as you can see that you are not going to get questions which are directly solvable by using the properties. So you have to manipulate and convert it into a property. For example, you are not going to get questions where it's of the form integration e to the power x, then we got like let us say log x plus 1 by x, because you know differentiation of log x is 1 by x, so it automatically follows the property. So according to the property, the answer is e to the power x into log x plus c. This is the answer, and I already taught you how to get e to the power x log x also. Is it clear? So it's not necessary that you have to show it. So you are not going to get such straightforward questions. You have to convert it into the property. Is that clear? So I will do one question where I'll teach you how we are going to convert it into the property. Okay, how we are going to convert it into the property. This is page number 387, question number 54 subdivision 2. Question number 54 subdivision 2. The question is integration e to the power x open bracket 1 plus sin x divided by 1 plus cos x dx. 1 plus cos x dx. Okay, this is ISC 2000. Now as you can see, e to the power x, so let us try to apply the property of by parts. So what is property of by parts? Whatever be the first function, the second function must be the differentiate value of the first. So please don't forget that. So integration e to the power x as it is, let us convert this into two functions. So what do I get? 1 divided by 1 plus cos x plus sin x divided by 1 plus cos x. I hope till here no problem. Then you know whenever you are dealing with trigonometry, I have to apply the formulas on trigonometry. I give you two formulas, one is multiple, the other one is submultiple. So this is submultiple. Y multiple, it becomes 2x, submultiple, it becomes x. So 1 plus cos x is nothing but 2 cos square x by 2 plus sin x is nothing but 2 sin x by 2, cos x by 2, these are the formulas. Then 1 plus cos x becomes 2 cos square x by 2. So as I've already told you, you don't get a question which is straightforward. You have to convert it into f and f dash. So moving on into the power ex, 1 by 2 as it is, cos is the reciprocal of sec square x by 2 plus 2 and 2 gets cancelled, cos and cos gets cancelled. So you got tan x by 2. Now did you convert it into two functions? So now you can easily see that when you differentiate tan x by 2, you will get sec square x by 2 and half. Is that clear? So that means this is the first function and this is the second, that means the differentiate value of the first. So let me write this properly, e to the power x tan x by 2 plus half sec square x by 2. So didn't I convert this in that form where the first is the any random function and the second is the differentiate value of the first. So some might get confused as to how differentiation of tan x by 2 is 1 by 2 sec square x by 2. So I'll just explain this once again. Tan standard or composite, so assume this as x. So what's the differentiation of tan x? It is sec square x, but this is just an assumption. So d by dx of x by 2, so you get sec square x by 2, 2 is a constant, comes out, and differentiation of x is 1. So don't you get 1 by 2 sec square x? So as you can see, this clearly satisfies the property of bypass. Therefore the answer of this is e to the power x into the function, that is tan x by 2 plus c. How did I get this? Using the property e to the power x f plus f dash will give you e to the power x into f. Is that clear? So as you can see from this particular topic, integration by parts, there are two things which you need to learn. Number one, you need to learn how to expand using the formulas of by parts, and second is to convert the equation into the property from which we can directly write down the property that I have already explained out here. Is that clear? The sums I'll be sending you PDFs, and for the property you can write few questions. Okay, I'll just do one more. So this is question number 55 from property, and next class I'll do questions on expansion of by parts. So one last question. Question number 55, it's integration e to the power x 2 plus sine 2x divided by 1 plus cos 2x. This is multiple angle. So e to the power x as it is, simplify this, 2 divided by 1 plus cos 2x plus sine 2x divided by 1 plus cos 2x. We have split this. Next, apply the formula. What is 1 plus cos 2x? It's 2 cos square x plus sine 2x will be 2 sine x cos x, and 1 plus cos 2x is 2 cos square x dx. So 2 and 2 gets cancelled. So integration e to the power x, 1 by cos square is sec square x plus 2 and 2 gets cancelled, cos and cos, sine by cos is tan x dx. So as you can see, this expression we convert into two functions. Now please arrange them in order. You can see when you differentiate sec square, you don't get tan x, isn't it? That means this can't be the first function. But when you differentiate tan x, don't you get sec square x? Yes or no? So that automatically this becomes the function and this becomes the differentiated value of the function. So using properties of by parts, the answer is e to the power x into the function, that is tan x plus c. I hope this is clear. So my dear students, please go through the notes. I'll be sending you PDFs, try those also, and if you have any problem you can WhatsApp me anytime. So next class we'll be doing few more questions from by parts. Thank you so much.